Hello. हेलो। दीपक आवाज आ रही है?
हाँ सर आ रहा।
ओके। तो जस्ट एक मिनट वेट हम कर लेते हैं, तो फिर उसको अलाउ करने के बाद वी जस्ट स्टार्टेड टुडे क्लास। Okay, fine. So shall we start? So today we are going to discuss equivalent circuit of the transformer. Okay. How we can represent their parameters in the circuit network form. Okay. So as we already seen that their phasor diagram and their various component, how we can relate, or their voltage equation, we observe that for the primary and secondary coil. Okay. So for the any electrical device, we can represent in circuit form that consists nothing but the main electrical parameters: resistance, inductance, capacitance, and voltage. Okay. So just we try to find out their voltage relation, how we can represent along the primary side and secondary side, and we can more easily analyze for the other performance of the transformer. Okay. So we already shown to you their systematic diagram and component of the resistance, reactance, and various type of core loss component. Okay. So just we try to see that how they can connected in a circuit form. Okay. So just we already seen that in the phasor diagram, there are two current component consist on the primary side current and secondary side current. Okay, and their relation between the voltage of primary side and primary side parameters and secondary side. Okay, so just try to see here. Is it clearly visible? Hello, Deepak.
Yes sir.
Is it clearly visible?
Yes sir, visible.
Okay. So we already seen that there in the primary component consists of two components. One is secondary side current, whatever the component is represented by I2, that will contract the secondary MMF, that means I2N2, and the other component is your IE, which is nothing but the exciting current, which is also consists of two parts. One is your core loss component, that is represented by IC, and another is your magnetizing current. Okay, so their relation we already discussed, IE, and that means exciting current, and IC and IM in phasor diagram when we discuss. Okay, So how we can relate this exciting current with the IC and IM? Have you remember? The vector addition of the core loss component, that means IC and IM. Okay, so IE square equal to nothing but IC square plus IM square, or you may find that IE equal to square root of IC square plus IM square. Is it not? So IC is your core loss component and IM is your magnetizing component. Okay. So IC is in phase with the voltage V1 dash. Okay. So the core loss component can be represented by PC, that is nothing but the I square R. So I square, that means IC, this is responsible for the core loss component. Okay. IC square into RC, or you may be either written as the V1 dash IC or V1 dash square RC. Okay, so you may find out from here IC equal to RC equal to V1 dash by IC, and magnetizing reactance, that means XM equal to V1 dash IM. Okay, so these two parameters we can find out if supply voltage given to you. That means V1 dash, that is nothing but almost equal to the EMF induced in the primary coil, and core loss component and magnetizing current if you provide it. Okay, so we can find out just core loss resistance and magnetizing reactance. Is it not? So this is all about the primary side parameters. Is it not? This is all about core loss component that consists of two parts. One is your RC and another magnetizing reactance. Okay. Now we already discussed that how we can refer the parameters of the secondary side to primary side. Okay, in the previous class. So just we try to here refer the parameters of the secondary side towards the primary side, or primary side to secondary side. So the resistance RC and XM are called the core loss resistance and magnetizing resistance. We already said that. So secondary resistance drop when referred to the primary. So secondary resistance drop, that means I2 R2 when referred to the primary, then we have to voltage multiply by the turns ratio. Is not? That means N1 by N2. So if we want to refer or transfer the secondary side resistance drop towards the primary side, then just directly multiply with the turns ratio. Okay. So secondary side resistance drop is nothing but I2 R2, okay, into turns ratio N1 by N2 multiply. Now we can just replace here I2, that is nothing but primary and secondary MMF are equal. So I1 N1 equal to I2 N2. Okay. From that equation, we can replace the value of I2 is nothing but I1 into N1 by N2. Is it not? If you primary MMF equal to secondary MMF, that means I1 N1 is equal to the I2 N2. So from that we can replace the value of I2 in terms of I1, that is nothing but I1 into N1 by N2 into R2 into N1 by N2. So if you simplify this equation, then you will get almost the value of I1 into N1 by N2 whole square R2. So this one is your I2 into R2 dash. Is not? Sorry, this one is your I1. So this one is your I1. That means I1 R2 dash. This is not I2. This one is I1. Na? So here is I1. This one is written as I2. So R2 is nothing but secondary side resistance referred to the primary side. Okay. Secondary side resistance referred to the primary side. So just allow. Now, so what is the total resistance in the primary circuit? प्राइमरी सर्किट में टोटल रेजिस्टेंस कितना होगा?
The primary resistance plus referred resistance.
प्राइमरी वाइंडिंग का जो रेजिस्टेंस होगा वो होगा प्लस व्हाट एवर द सेकेंडरी रेजिस्टेंस वी ट्रांसफर टुवर्ड्स द प्राइमरी साइड. Okay, so the summation of, or you maybe say that both the resistance are in series, so equivalent resistance, if two resistance are in series, so directly summation of these two resistance, that means R1 plus secondary side resistance refer to the primary side, so R2 into N1 by N2 whole square, so that is represented by R1 plus R2 dash. This is your total resistance refer to the equivalent resistance, so that means along the primary side. Okay, similarly, if you want to transfer the primary side resistance towards the secondary side, so can we transfer? What is the value of primary side resistance refer to the secondary side plus secondary side resistance? So secondary side resistance is R2, and primary side, when you refer towards the secondary side, that means how much? R1 into N2 by N1 whole square. So total resistance when refer to the secondary side is R2 plus R1 dash. Okay. Similarly, we can represent the leakage reactance along the primary side and secondary side. प्राइमरी साइड में कितना हो जाएगा टोटल रेजिस्टेंस? यदि सेकेंडरी लीकेज रिएक्टेंस इफ यू ट्रांसफर टुवर्ड्स द प्राइमरी, कितना हो जाएगा? सेम चीज हो जाएगा ना, सिर्फ रेजिस्टेंस की जगह क्या हो जाएगा? रिएक्टेंस. यहाँ पे रेजिस्टेंस का भी ऑलरेडी राइट. So similarly, we can find out for the leakage reactance transfer either along the primary side or secondary side. Just tell me, what is the total resistance or equivalent resistance towards the primary side? Leakage reactance. कितना होगा? टोटल लीकेज रिएक्टेंस टुवर्ड्स द प्राइमरी साइड कितना हो जाएगा? XE1 इक्वल टू कितना हो जाएगा? X1 in place of R1, X1 plus X2 N1 by N2 whole square. That means X1 plus X2 dash. Is it not? नहीं लिख सकते हम लोग X equivalent towards the primary side and X equivalent towards the secondary side. Secondary side कितना हो जाएगा? यहाँ पे जस्ट रेजिस्टेंस की जगह पे हम लोग को क्या पुट करना है? रिएक्टेंस. तो रेजिस्टेंस को कैसे रिप्रेजेंट करेंगे? रिएक्टेंस को X से. तो XE2 that means refer to the total resistance towards the secondary side. तो secondary side का reactance that means X2 plus X1 refer to the secondary side. So X1 into N2 by N1 whole square. That means R2 plus R1, X2 plus X1 dash. रेजिस्टेंस के लिए हो जाएगा. Is not? So just already shown here. That means transfer to the total reactance towards the primary side. That is nothing but the X1 plus secondary side leakage reactance transfer to the primary side. So that means X1 plus X2 dash, and XE2 is nothing but the total or equivalent leakage reactance towards the secondary side referred to. So X2 plus X1 N2 by N1 के whole square. Okay. That means total resistance of the primary winding or secondary winding can be referred to the either primary side or secondary side. So just try to see how we can connect this circuit, all the parameters. Okay. So this is the, in the exciting current you have neglected. Okay. Then the circuit is just simply look like that is supply voltage that is represented by V1 systematic. R1 is your resistance of the primary coil and X1 is your leakage reactance. And exciting current we have already neglected, so we are not showing here the component of IE only. Here shown the I1 and secondary side parameters. Just this is your secondary terminal voltage V2, and this is your secondary side leakage impedance, that means X2 and R2. So current flowing in the secondary coil is your I2. Okay. If you consider that means the exciting current, so we already write their equation of RC and XM. So RC equal to V1 by IC. So RC and XM are consist of two component of an exciting current, that means IC and IN. These are in parallel with the connected in shunt branch. So this is all component of the primary side. That means primary impedance, that means represented by R1 and X1, and this is your, we have already said that some minutes earlier, that means I1 consists of two components. One is your exciting current that is represented by I, and another is your load component of the secondary side current, that means I2, that is totally contrast the MMF of the secondary side, that means I2 into, that is represented by I1 dash. That means whatever the load current turns toward the secondary side for the load, that is equivalent to yes, just tell me.
सर हम लोग का सर एक और क्लास है अभी सर
अभी
10:45 से
10:45 से
यस सर
okay, fine. So schedule you have to provide it, no? I think. Okay, so can we reschedule this class whenever you are free?
Yes, sir.
Are you free in the second half? Second half में है कोई क्लास खाली एक्चुअली
सर लैब है इलेक्ट्रॉनिक्स का
इलेक्ट्रॉनिक्स का लैब है ना okay, so let's we stop here and this class will be rescheduled whenever we got the slot. Okay, so just we stop here. I can do it. Thank you. Okay.